Our next speaker will be Michael Guymon with Maxwell Products. Michael is a materials specialist, and he'll be talking about mastic applications.
This is Mike Guymon. I'm the materials engineer at Maxwell Products, and I have been studying mastic materials now for about 16 years. One of the surprising things to me is that most of the materials that we have placed in test sections in hundreds of different locations are still in place after many, many years. So I'd like to talk to you today a little bit about the evolution of mastics and also the specification, which I had a small part in bringing to pass. As we go here, I'm going to talk to you a little bit about how mastics came about here in the United States, and also give a little bit of, at the end of our last conversation, Larry asked me if I would talk a little bit about mastics. These are not emulsions. Mastics are hot applied, highly polymer modified asphaltic binders combined with select aggregate in a homogeneous blend. Mastics are void-free and require no compaction. They have a degree of structural strength to handle load and resist deformation and breaking with impact. Mastics are becoming increasingly important implements in the pavement preservation toolkit. It would be hard to find a more versatile, effective, and budget-stretching product for a wide range of pavement problems. These products can stand alone or work in conjunction with other preservation treatments to lengthen the life of pavement, or they can provide a temporary fix when needed. The specification defines the products as hot applied, asphalt-filled mastics. Materials called mastics have been around from the early 2000s in the United States. They are made of asphalt with select binders and aggregates which seal and level various pavement defects. For us, mastics originally leveled defects like cup transverse cracks, wide transverse cracks, and longitudinal cracks and shallow depressions. European and American patents shaped and expanded the development of mastics as formulators created new products in ways that wouldn't infringe on the patents. As different manufacturers added products, their use cases multiplied fast, and engineers began to look for standards they could use to apply them. The formed in place for joints and cracks in pavement subcommittee of the ASTM Road and Paving Materials Committee started working on this in 2015. I remember when a task force was formed with Lowell Parkinson and several other individuals. There was a lot of give and take back and forth, and we produced a specification for 3 climate zones in 2018. The preliminary specifications balloted in 2019 and were reviewed by the ASTM organization and were published in 2020. Additional work needs to be done. A precision and bias statement has yet to be performed. Why this is important, and actually may take several years to do that, the 3 things that are really important are repeatability, reproducibility, and also accuracy. How did we arrive at the specifications? It wasn't easy. Keep in mind, I was only one of many people in the room, and this is my own perspective, and I actually had less to do with the specification than many of the other people that were there. Many points of view weighed in on these specifications on the manufacturing side. The lab rats, well, that's me, the sales and marketing people and managers all had things they wanted to include and exclude. The DOTs and other government stakeholders had their votes too. How did we satisfy these entities? Well, the open secret is that we probably didn't perfectly satisfy any of them, but we think we came to a workable compromise. Mastics have a wide range of uses, effectively preserving highways, county roads, city streets, bike and jogging paths, parking lots, bridges, drains, school playgrounds, and more. And there's the matter of the defects being fixed. Over the years, the uses for some mastics had widened from potholes and cupped transverse cracks to wide longitudinal cracks and cold seams to alligator cracking, rutting, raveling, utility cuts, really monster potholes, depressions, and drainage issues, and more. Some producers approached their products as a one-size-fits-all, and others created tailored products with more specialization. This specification covers hot applied asphalt aggregate filled mastics for repairing distresses in asphalt pavements and hydraulic concrete pavements. These distresses include, but are not limited to, depressions, wide cracks, not suitable for crack sealing, potholes, corner breaks, and longitudinal joint distresses, and other repairs smaller than those requiring remove and replace procedures. The key phrase is limited to. You who regularly use these products know their potential uses actually go somewhat beyond that. As products and applications continue to improve, so will the range of problems that will be solved. At present, some formulations of these products work for alligator areas, spalls, delaminated overlays, rumble strip rehabilitations, and even bridge joints. The purpose of the specification is to make these products available to state transportation and highway departments, and you all could have reasonable confidence in what you are getting. One thing we avoided is repeating a characteristic of the D6690 crack and seal joint spec, where the specifications lean heavily toward a cold weather sealant. As a result, we have airports in Arizona being crack sealed with something that was developed, as it were, for Minnesota. After some lengthy discussions, we decided on hot to very hot, moderate to cold, and cold to very cold, cleverly named 1, 2, and 3. The map is somewhat misleading, however, because in Utah, for example, depending on elevation, we have actually all 3 zones within one state. All right, so I want to talk a little bit about the different tests, and these are things that we all had to agree on. I mean, that they would mean something. So this is what it means to me a little bit. The resilience test indicates resistance to pushing, shoving, and printing. Measure dimensions, put it in a press. It has to go back to 50% of its original shape. We think this will lead to products that will stay put in their original form for quite a while. When I first observed the need for this, I saw tire prints being formed by traffic. They would appear in a few moments, and then with a new vehicle passed over it, it left its own temporary tracks. The formulations that did this stayed in place and shape for a long time. The next test, we all know that mastic materials are placed in materials where there's a lot of movement and also rapid deformation or shock or impact. 3 climate zones seen as resistance to shock applies to impact from snow plows, truck and vehicle traffic. A frozen sample is placed in the apparatus and a shaped weight is dropped on it. Does the sample chip, crack, or separate at the target temperature? Crack bridging approximates performance on transverse cracks as they move, especially in cold temperatures. Also in 3 climate zones, concrete blocks are placed together and mastic is poured on top. Blocks are equilibrated and then slowly pulled apart by 1/8 of an inch at 1/8 of an inch per hour. The 4th test, stability, approximates resistance to deformation at highest anticipated pavement temperature within a climate zone. For example, if it's in Phoenix, Arizona, on a 110-degree day, the pavement temperature could be 160 degrees Fahrenheit. We needed to know that our materials would be able to handle a little bit of deformation from above when it's hot outside. There are many products that may perform very well that won't fit the specification profile. Equally important to know is that a particular product could perform marginally in the field and still meet the specification. In other words, you still need to make us, the manufacturers, prove that our materials work in the field. One other concern I have about the specification, because we have a spec, we could, as manufacturers, be tempted to stop innovating, and these products commoditize, development stops too soon. I promise that if that doesn't happen, these products, good as they are, will be better in a few years if we keep working on them. We hope the users, many of you, will keep an open mind for new innovations, because as far as we've come with mastics, the best is yet to come. Mastics are becoming increasingly important implements in the pavement preservation toolkit. They are proving to be versatile, effective, and budget-stretching solutions for a wide range of pavement problems. Mastics can stand alone or work in conjunction with other preservation treatments to significantly lengthen the life of your pavements or to provide a temporary fix when needed. With the right tools and properly formulated products, we see Mastics as the versatile tool that can smooth out the defects that have formed in your roads, pre-treat the bad stuff to lengthen the life of your seal coats, micros, slurries, thin lift overlays, and chip seals, and keep our roads serviceable and comfortable to drive. Could be that some tough times are ahead with budgets and revenues. Mastics will absolutely help us get through this. Thank you for your time.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.